Now somebody's probably out there screaming at their computer screen saying, "You just took me through all of that to prove that a bullet flies in a parabolic trajectory and drops over time?" Yes, I did. That's right. Now why? Because let's see how that principle applies to aiming. If I'm going to shoot and I've got a gun sight that's sighted in 100 meters, then, of course, the center, when the target's at 100 meters, will be dead on. Now, if I start taking even distance ticks down the gun sight, they correspond to increasingly smaller gaps in distance. Now, why? Because, okay, if this is at 200 meters, and the next one's only 260 meters, the reason is that there's been more vertical drop of the bullet over a shorter distance. The next one's only 40. The next one's only 25. Now this isn't actually a real calculation. I'm just giving this as an example of how it works. And what I'm trying to show you now is that over distance, aim becomes more difficult because you have to have a reference point. The sight is your reference point. It's doing what it's supposed to do, except that if you're off by 5 meters here, that's a lot more than being off by 5 meters here when you judge the distance, because you don't know how far you are, right? Unless you've got icons on and exact distance is being reported to you. You don't know. So now we've only talked about the simplest of motion in terms of an attack situation. What happens when now I'm in my Gotha and the gun is shooting out the back, but my plane moving forward actually drops my muzzle velocity? Not to mention now I've got a spat on my tail. His velocity is also something to take into account, because when I shoot, if I shoot at position 0 here, and he's at 150, negative 150 on the x-axis, back here, by the time my bullet reaches him, he'll be at like negative 100, somewhere in here, right? So, in this case, the faster he's traveling towards me, the easier it is to aim, or the less I have to aim up, I would say, to calculate and compensate for gravity. And if that's not enough, well, now let's talk about side-to-side motion. So I have the SPAD here, who's not just traveling in a sideways or a forward direction. He's traveling diagonally. And not only is he traveling diagonally, I'm traveling diagonally in order to compensate. Well, now the bullet has to account for motion in 2 axes of travel. Oh, wait, no, it has to account for a third, right? Gravity. That never stops. So the force of the effect on the bullet can be broken out into its subcomponents. Okay, so any bullet, anything traveling in any direction can always have its relative forces and velocities broken out into x, y, and z components. The enemy plane, muzzle velocity, air resistance, my plane. No big deal, right? Oh, wait, no, it just gets more complicated. Yeah. So this is what a rear gunner is dealing with in an average situation. Okay? It's even more complicated than the last slide. I've got my Gotha here. I'm moving forward. I'm climbing. I'm in a left-hand turn at the same time. My enemy is coming forward. He's diving, and he's in a right-hand turn. Well, that means my bullet has air resistance and muzzle velocity acting on it in 3 directions, plus gravity, Plus, all these other little vectors, all these play into the bullet as well and how it moves. Okay, so are you starting to understand why this is such a headache for a rear gunner to aim? Or is it giving you a headache just looking at it? Now, if you're not convinced, you don't see it yet maybe, the next slide should do the trick. So, given the previous slide, this is what I would see in terms of forces were I looking down the barrel of my gun in the rear seat of the Gotha up at that SPAD, and how I would aim relatively. Now, not in regards to the exact position of the sight here versus the plane, but that's what I would take into account, these 13 forces, when I was choosing where to place my gun sight relative to the plane. Some of these, pretty straightforward. Air resistance. Well, air resistance slows my bullet down. Therefore, I have to move the gun sight farther in each of those directions to accommodate air resistance. Yeah, pretty straightforward. Muzzle velocity works the other way. Higher muzzle velocity means the bullet travels farther before it starts dropping. Therefore, higher muzzle velocity means that I can afford to aim lower in each of these directions. Now, lower relative in terms of the axes. So, I'm not saying that each of these will drop me vertically. I'm saying in relation to these axes here that I've drawn on the gun sight. Now, what about my plane and the enemy plane? Well, if you think about my plane, which is climbing, and his plane, which is descending, both of those means that we're technically converging vertically, which means I can afford to aim lower in the vertical direction. But what about traveling side to side? I'm turning left, he's turning right. Z direction and the Z direction. Well, the fact that we're moving in opposite directions, side to side, means that I'm going to have to increase my aim in that direction. And finally, in the Y direction, not to mention you already got gravity, in the X direction, you have the enemy and you have my plane. Now, not knowing the exact speed of how those are relative to one another moving forwards, it's actually conceivable that this could flip and that my plane would be decreasing my elevation of my gun sight and the enemy would be increasing, but we just don't know. So either way, they're going to have some effect horizontally. That's a lot to keep track of. And just to pile it on, because that wasn't enough, remember that all those diagrams and equations, that's only for a snapshot in time, right? You'll have to constantly adjust for the target's pitch, roll, and yaw, because remember, his velocity isn't a constant unless he's flying in one direction. It's changing as he maneuvers. Same with your plane. Your velocity is not a constant. It will change relative to direction. And all those MGs and the 20mm cannon, each of those have different muzzle velocities and unique gun sights, which means in order to master backseat gunnery, to know it through and through, you have to know the relative velocities and how to aim the sights for each one individually. It's 3 separate studies. Well, that's a heck of a lot of work. And even if you could do all the equations on the fly in your head, if you were Einstein or the equivalent, you don't have the data in game as a gunner in order to do it. Okay, there's no field mod radar, and there never will be, that's spitting out enemy plane approaching forward velocity 45 meters per second x 17y. No, okay, not going to happen. So how do you aim then if you don't have the equations? When you can't do them that fast? Guesswork and practice, which is really just repetition based on guesswork and application. But don't worry, there's light at the end of the tunnel. Before you decide it's all just too hard, and you throw up your hands and say to heck with it, tune in for the next video. Backseat Gunnery, let's get practical.